Hey, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, Houston, we have a problem. I want to talk today about multi-step mole problems. So these can be tricky, but ultimately what it comes down to is that there are three key fractions when you're doing mole conversions that you need to pay attention to. So if you recall from previous videos, we can say that there is so many grams in 1 mole. Now this we're saying mm, that's the molar mass. So you take your periodic table, right? You take your periodic table and you add up the molar masses. We're going to call this fraction number 1, okay? The second fraction when we're doing mole conversions is there's 6.02, you can say 22, times 10 or e23rd particles in 1 mole. We'll call that fraction number 2. And by the way, remember, a particle can either be an atom or a molecule. And then the third fraction only applies to gases, and it says there's 22.4 liters in 1 mole. These are of gases, at a particular thing called STP, which stands for standard temperature and pressure. Standard temperature is 0 Celsius, standard pressure is 1 atmosphere pressure, or pressure you would have at sea level on an average day. So this only applies to gases, okay? Now we're going to use those in solving problems. So let's just do several problems. So keep those there. These three fractions are super important for you to keep track of. So let's say that I have, question number 1, I've got 8.32 grams of carbon dioxide, and I want to convert that to liters, or we could say volume, right? So I start with what I know is a fraction over 1, so I'll say 8.32 grams CO2 over 1. Now I have to ask myself, which of these three fractions can I use? Now the one I have to use, the only one with grams, and I want to convert to liters, but there's grams to moles, particles to moles, liters to moles. I do not have grams to liters, but I do have grams to moles. So what I would do is I would say, I kind of leave a blank here, watch how I do that, grams in 1 mole. Now where do I get this number? I look at my trusty periodic table, and it's carbon dioxide. Carbon weighs 12, plus oxygen weighs 16, so 16 times 2, that adds up to 44. So that's the number that goes here. So you have to, if you have to use fraction 1, you will always have to find the molar mass of your compound. And if I want to go to liters, now notice that the grams cancel. It's really moles of CO2, right? And now I want to convert to liters, and so I'm going to have to use which of the three fractions. And as a note, actually, let me back up. Notice that I wrote this fraction upside down because these are conversion factors, so they can be flipped one way or the other. And then lastly, I can say 1 mole of CO2, I'm going to use fraction 3, is 22.4 liters of CO2. The moles of CO2 cancel, and now the only label unit I have left is liters of CO2, so I get my calculator out, and everything on top you times, so on the bottom you divide, so 8.32 divided by 44 times 22.4, I get 4 point, and that'll be 24 liters of CO2. Now I rounded to significant digits, so you want to work on that. So for our next example, let's say we've got this many atoms of lead, and I want to convert to grams. So you always start with what you know. So fraction number 1, 6.3. I'll just say E20 atoms, or AT, over 1. Now I want to get rid of atoms, and I want to go to grams. So I've got a fraction 1, 2, 3. Hopefully you see that you need to use fraction 2 first. Because remember, a particle is an atom. Now, watch what I'm going to do. I'm going to write atoms here. I'm going to say 1 mole, right? That's 1 mole. And this number is always the same number, 6.02, technically 6.0222 E23. We can round it to 6.02. The atoms cancel, and I'm at moles. So now what I want to do is I need to get from moles to grams. So I'm going to use fraction 1. Now in this case, I want the moles to go away, so I'll say moles to grams, 1 mole, And this number, I have to figure out what that is. So I get my periodic table out. Lead weighs 207, I believe. Yeah, or 207. You don't necessarily need the 0.2. So remember on your calculator, it's kind of weird how you type that in here. I'm going to say 6.3 EE20 divided by 6.02 E23 times 207.2 gives me 0.217, and that will be grams. And I think with sig figs, it's at 0.22 grams. So essentially what you're going to do on these problems is you've got these three fractions, right? If I want to convert from liters to grams, I'm going to use these two, right? If I want to go from particles to liters, I'm going to use these two. If I want to go from particles to liters, I'll use these. I mean, you're going to use any combination of those three fractions. Essentially what you're doing is you're converting from something to moles and then from moles to something else. And these are what we call multi-step problems. Houston, we don't have a problem. We'll see you in class.